Hey, and here are home plate.
All right.
Security in multiple instances in a single RADOS cluster. Off we go.
All right. So this blueprint is basically a plea for people to come and give us information about what they want to do. And so the reason for that is that one of the things that has been popular to talk about with some of our developers lately has been adding support for multiple CephFS file systems within a single RADOS cluster. I don't know that we're likely to implement it, but there are a couple of different approaches to how we can do it that are bound up with, and they sort of have different security versus convenience guarantees. And security is also a thing which we know is a big deal for many people, so that I think will impact how we go about doing multiple file systems if we ever do it. So I want to talk about both of those. So unfortunately, I didn't put very much detail in here. I'm afraid I just dashed this blueprint off. But there's sort of two approaches you can see that I can see for doing multiple file systems. The first one is one that Sage has championed, which is where we say, okay, we're going to allow any number of file systems within the cluster, and we're going to do that by having multiple MDS maps that specify different pools for the data and metadata for each one, and that mean that we have a different set of MDSs for each file system, and clients, when they connect, have to tell you which file system they're connecting to. So that has some advantages in terms of the file system code. It's a lot simpler. It's more work in the monitors, but it's very simple for the file system because basically nothing changes, except that it has to deal with, like, when you're turning it on, you have to tell it which one it belongs to so it can tell the monitor. It gets us some fairly effective multi-tenancy features very, very cheaply. Just we would need to sort of specify a much stronger MDS CephX authentication capabilities system, so you can specify the file systems you're allowed to talk to. But once you do that, then basically you can have physically segregated file systems for every tenant within a shared resource cluster. The downside to that is that you have a different metadata server or a cluster of metadata servers and a different set of RADOS pools for every file system. So there's no load sharing. So the other way we could go.
Sorry, what was the last thing? Different set of standby MDSs.
Ever say standby MDSs? No, just a different set of MDSs in general. Like each file system has its own with that are getting the map for that file system and everything. Now, I mean, standbys are another thing that the monitor has to cope with, but in terms of the generic stuff, that's not a real big deal.
Okay.
So the alternative approach is one that I'm not sure that I'm not sure that I'm a real big fan of this one either, but it's sort of, I think it's more philosophically in line with some of the things that Ceph was trying to do when it started out, where it was sort of easing the job of the administrator, which is that we already have this system that allows you to mount a subtree of the file system on a client and stay within that subtree. So we could put a little bit better fencing around that and a lot of syntactic sugar, and basically just have multiple file systems implemented as directories within a file system with syntactic sugar around them, so that you can reasonably say, I want this client to have access to file system A, which is just a directory in the root, but we don't care about that. And then you get much better, and then you don't need to make the changes to the monitor that allow multiple things within that'll allow multiple file systems within a cluster. You just have the syntactic sugar, and you also get all the benefits of load balancing across your clients. Of course, that means that you need a stable multi-MDS implementation, because otherwise all your clients are stuck with one MDS. And also, you need a real file system security setup, which we don't have yet, because you don't have any physical separation. But so that would be good to talk about, like which of those are more important to people who think they might deploy something that looks like multiple file systems within a cluster. But more importantly, or not more importantly, but also I want to talk about like the security expectations that people have, because if the multi-tenancy by way of multiple MDSs isn't strong enough, then it's less interesting as a thing to implement. If we would need to implement a serious and capable security system within our normal setup anyway, then maybe we just want to do that and not make all these changes to the monitor and allow for the sort of administrative simplicity of just having a big pool of metadata servers. I don't have any answers there. Basically, I'm hoping that people will hear about this and then come and tell us use cases that they have.
Yep. It's funny when we talked about this earlier. I thought I totally misunderstood your option 2. I thought your option 2 was suggesting that you'd have one MDS map structure, but every field in it would have like a mapping file system to all the different things. I was like, that's not a good idea.
No, that would be a poor idea.
No. Yeah. So honestly, I think that both of these things are things that we want to do, and there are different reasons for doing each of them. Like option 2 is really just about being able to have an MDS capability that locks you into a subdirectory. Because you're right, this is so option 2 is totally the model that I think we always envisioned in the past, where the whole point is that you don't want to have subvolumes, you just want to have directories that you can do everything you can normally do with directories, and you just mount a subdirectory and lock a client into them. I think the problem is that there are a couple of things that doesn't capture. It doesn't give you fault tolerance or performance isolation. So if you have one file system that's like just logs or something, and another one that needs to be fast, they all get sort of jumbled up in the same set of MDSs. And maybe you have administrator commands that sort of lock subtrees into different classes, and you sort of have a service overlay substructure to your MDS cluster where you have, it's not just a flat array of MDSs, but you say, I want this subtree to stay on this MDS and this subtree to stay on that one, like that, which would give you some of that. But I think just from a high level, if we did our job perfectly, then yes. But at the same time, you can imagine cases where you have different rooms of a data. You could have a cluster that spans different data centers. You could have totally different use cases.
There's a little bit more to it though than this, though.
Yeah.
So it's not just about locking people into a certain location. It would really be like having a proper security model that's enforced on the server sides. And the advantage to going through all that trouble is that then you can do things like have different tenant, like have a tenant share its data with other tenants, whereas you can't do that at all.
Which I think we do. Right.
If they're
so we definitely want
servers.
We want a workstation to be able to mount home user and be locked in there, right? Like that's an important use case that we want to capture. And so the way that I've always sort of imagined that would work would be that the MDS capability essentially for that CephFS user or whatever would basically just say, allow MDS in path home foo, and the MDS would just verify that the inodes that you're caching and operating on and doing all the stuff, that they are just within that subtree. That was sort of how I assumed that might work. And that captures sort of the like subvolume use case too.
Yeah, but I mean, there's more to it than that though. Like, for instance, I mean, really generally what you would expect is that actually they can only do stuff in their own home directory. But then maybe there is someone who's like got globally shared stuff they want everyone to be able to just access from wherever. So you want to be able to do that as well.
And the capability would do that, right? It would say allow read write home foo, allow read home shared, or allow star. You get the whole thing, right? It's an access, or it's a set of grants, whatever you call that.
Yeah. Well, but I mean, also think about an actual multi-tenancy system where it's not just different users in the file system, but actually tenants within like a cloud data structure within a cloud data center, where one of them is like, where in general they all do on private files, but then one of them is like, I want to share this location of my stuff with everyone who comes along looking for it. And you can't just have them, and you can't just give everyone a grant to that. That needs to be like a publicly available thing that they can somehow ask for, and just get hooked up.
Yeah.
Well,
yeah. Okay. So, well, I mean, so that's, I guess that.
And also sort of a mapping really to the Unix permissions, because right now we just rely on the client to like not to be polite about it, whereas we would need some sort of remapping saying, okay, they're this user internally and all that sort of thing.
Yeah, I guess so I think option 2 is in my mind is largely about security and multi-tenancy, and I think the problem I has is it would be difficult to convince a paranoid user that we've sort of covered all our bases, because our client server protocol, or client MDS protocol, is inherently very trusting of the client. So the clients are like allocating inodes and doing all this stuff. They're doing all kinds of stuff, and so it's a lot of holes to sort of close and convince them that even that they like can't exploit a bug in the MDS. And so whereas I think option 1 for me is a little bit, it's even less about, I guess it's still about security, but it's more about the type of hardware you're deploying on, and having things that are completely independent. So in the same way that you create RADOS pools that can be mapped to different hardware, you could create file systems where you have, I just want a completely different set of MDS. I want like one MDS that I'm going to like pound to death because this is like a use case where it doesn't really matter, and I'm going to map it onto a SATA pool of RADOS. Whereas this other one, I'm going to back it with something else that's my home directories, and I want it to be totally independent from my databases or something. It's the same way that you would you can create multiple RADOS gateway zones within a cluster, and you have a different set of RADOS gateways that are sort of sitting in front of them. Like you can architect where the daemons go and how they're mapped onto the RADOS layer that way.
Anyway, I mean, I certainly see the use cases for both of them. It's mostly just that I want to hear from users about what the overlaps are and sort of where their relative priorities are, because they're two big projects that we are unlikely to work on at the same time. And I mean, not necessarily soon either, but if it turns out that like multiple MDSs are a key thing for a whole lot of people, and it would satisfy their security requirements for 85% of use cases, then I'd become a lot more interested in working on it soon.
Yeah. Well, I think part of it comes down to, in the cases where people want security isolation for that multi-tenancy, is it because they want it for like hundreds of users, or because they have like 3 use cases that are like logically different, like 3 tenants that could be satisfied by 3 independent clusters? Or is it really that like they want every home directory to have their own little whatever? I think that sort of, for me, determines whether it sort of pushes things towards one or not. I think the other thing with option 2 is that the security enforcement that we need to address that is also the same thing we need to do in order to eliminate some of the trust on the client that you currently have when you're using, for example, CephFS or libCephFS. Where you have a potential user level process that is, you kind of have to grant root access to the file system in order to.
Definitely.
It's like I think the Hadoop use case might be one where that is going to become important. Like if you're running Hadoop in a semi-untrusted environment. Anyway, anybody who's in the room have questions? Should we leave that as the video record? All right. Good enough for me.
Likewise.
All right.
Yeah. Cool.
All right. I think that's the bulk of it. Then we have completed it.
Like we're done.
Hooray! Which is good
We did
because
it.
I think my connection is dying.